Hey there, it's Friday, May 29th. We're going to do the notes for the very last section of chapter 10. I know there's a 10.7. It's all about interquartile range and measures of center and all that. We're going to make this our last section of notes in the interest of time. So here's our warm-up. It's find the probability of compound events. You really need to know how to do this. So pause the video, give these 4 a shot, and then come back and we'll review. Okay, here we go. So to find the probability of a compound event or more than one event occurring, you need to find the probability of each event and multiply them. So you flip a coin and roll a number cube. Find the probability of the event. So there are 2 sides to every coin, a heads and a tails. So the probability of flipping heads is 1 out of 2. The probability of rolling a 6, there's only 1 6 on a number cube out of the 6 possible options. And to find the probability of doing both of these things, we're going to multiply straight across. 1 times 1 is 1, and 6 times 2 is 12. Let's keep going. Again, the probability of flipping heads is 1 out of 2. And the probability of rolling an odd number, there are 3 odd numbers out of 6 options. Now we're going to multiply 3 times 1, 6 times 2. Oh, you could reduce that. 3 goes into 12 evenly 4 times. So our final answer is going to be 1/4. Number 3. Again, the probability of flipping a heads is 1/2. The probability of rolling a number greater than 3. 4, 5, and 6 are greater than 3. So our probability is going to be the same as it was before, 1/4. Last one, the probability of flipping tails and rolling a number less than 5. 1, 2, 3, and 4 are all less than 5. So that's 4 out of 6 options. You can cross cancel if you want to. 4 times 1 is 4, 2 times 6 is 12, and that goes evenly 1/3. All right, I hope you have 10.6 notes in front of you. If you don't, they're available on my website and are not required, but it's a nice resource to have if you do have them. Here's our essential question. How can you determine whether a sample is accurately represents a population? So we're going to talk about real-world things about populations and samples. When we survey to find out information about anything, we usually don't survey every single person, right? We survey a sampling of everyone in the total population. So if we wanted to take a survey of all the 7th graders, we probably wouldn't ask them all. We would ask some of them or a random mix of them to make it easier to collect that data. Now, to make our data accurate, we have to make sure that our sampling is very random and not biased in any way. Now, that word bias means that it is purposefully swayed in one direction, where they purposefully choose or accidentally choose people who may already have preconceived notions about whatever you're talking about. Let's talk about some examples. Here we go. It says, you want to estimate the number of students in a high school who ride the school bus. And we want to choose a really good sampling of people in the high school. We don't want to choose a sample which might skew our results in any way. So we want to make sure that our sample is big enough, random enough, and a good representation of everybody in the high school, not just a group. So we need to pick the best one. Look at number A, letter A. 4 students in the hallway. This sample size is too small. You need to ask more people. 4 people is not enough to represent the entire high school. Look at letter B. All the students in the marching band. Now, if you're in the marching band in high school, you have 0 period. you can't ride the bus. You're targeting a group of people, and this group of people are going to have the same issues as everyone else in this group of people. It's a specific group and it's an issue. We can't use that. It's too specific. It's not random. What about letter C? 50 seniors at random. We're getting better because it's random, but we specifically targeted the seniors. The seniors can drive. They don't take the school bus anymore. They drive their car to school. So since we targeted this specific group, it wrecked our data. We can't use that. But look at the last one. They surveyed 100 students at random during lunch. Every grade level's at lunch. Every group is at lunch. 100 students is plenty big. It's random. This is our best sampling. It's the best group to represent everyone in the high school. Now, even though there might be 1,000 students at the high school, 100 is a good size. It's better than 4. So we want to make sure that it's big enough and very random. Now, when we target specific groups, we ruin the data. So in order to make a valid conclusion about whatever our issue is, we need to make sure that the people that we talk to are random. So let's decide. It says you want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. Now, a conclusion would be invalid if we ask the wrong people. So, the first one says you survey 20 residents who live closest to the new sign. 15 support the sign, 5 do not. So you conclude that 75% of all the residents in your town support the sign. Now, they targeted this specific group of people who live closest to the sign. And since they targeted these people, they skewed the data. Their conclusions are not valid. Let's look at this one. This one's better. You surveyed 100 residents at random, not targeted by their address. This is a much more valid conclusion as it relates to the sign and whether the town supports it or not. So we want to make sure that our grouping is completely random. Let's try one last one. Let's talk about this top one. It says you want to estimate the number of seniors in a high school who ride the bus. Well, you'll want to ask the seniors now because it specifically addresses the seniors, and that's okay. Let's look at number 2. You want to estimate the number of 8th grade students in your school who consider it relaxing to listen to music. You randomly survey 15 members of the band. Your friend surveys every 5th student whose name appears on an alphabetical list of 8th graders. Which sample is unbiased? So I want you to think about this one for a second. Whose is more random, yours or your friend's? Your friend's is more random. So the friend has a more valid conclusion. Because if you're surveying people in the band, they already have preconceived notions about music. They already like music. So your data is going to be inaccurate. It's going to be skewed. So your friend's is more random. It's more unbiased. Now practice on some homework tonight. Make sure you're getting the help that you need. Next week on Tuesday, I'll be having office hours again. This homework that you start today on Friday the 29th isn't due until Monday afternoon, so spend some time on it, and then we'll review in preparation for Chapter 10 tests next week. See you soon.